So again, our I can statement, that's what we're going to be doing during the lesson today. We want to be able to rewrite, and that is one of the worst words for me to say. If y'all can say that well, rewrite. I feel like if I don't enunciate, I'll be like, Anyways, I can rewrite and use literal equations to solve problems. So a literal equation is just... So do we know what an equation is? Equation is a math statement that has an equal sign. A literal equation means we're going to have a lot of variables, more than one variable in that equation. So a lot of people call those formulas. Formulas are a kind of literal equation. So they're kind of used interchangeably. So let's look here at our intro to the lesson. It says, Nora drew a non-square rectangle. Then she drew the length of each side from end to end to make a line segment to represent the perimeter. So we can see here she's drawn this rectangle with widths and lengths, and then she basically unfolded this box, right, and laid it out end to end. So we can see a length, a width, and a width. It says to write an equation that represents the perimeter of the model shown. So does everyone remember what perimeter is? Distance around the outside. We talked about that some last lesson. So if we're going to find the perimeter, how could we find the distance around the outside? So this is open suggestions. Y'all can tell me what you think.
Outside to get the area.
So if you multiply the outside, that gives us the area. The area is how much is covered inside, right? That's what area is. Area would be the amount covered inside. But perimeter is like a fence. If you were going to put up a fence, how much perimeter fencing, how much distance do we need to put up that fence around the outside? So if we're having to write an equation, we're going to use something that has an equal sign. So let's say that the perimeter is going to equal, that's the way we're going to start it. And then how could we find the perimeter of this rectangle? Add it all up. So what would that look like? I agree with you. You're right. You just add it all up. So what are the side lengths? So like what is this side? L. This one is W. Right, and you can kind of see that where it's laid out here, right? L plus W plus L plus W. Well, could we simplify that any? Do we have anything that's like terms? We do. W and W are alike. L and L are alike. So what is W plus W? 2W, yes. So the perimeter would be 2 widths plus, and then L plus L. 2 lengths. So that's how we find the perimeter of a rectangle. 2 widths plus 2 lengths. That's for any rectangle. All right? Questions on A part. B says to rearrange the order of the sides so you can represent the perimeter with a different equation. Well, I've already done that. Sorry. So I need to start reading ahead. Okay, so their first one is L plus W plus L plus W. Right? Now, we've already rearranged that to make it into 2W plus 2L. So really, this is the first answer. That one's A part. And B part is the second answer. Now, how many different ways could we express the relationship in parts A and B, and are any of them more useful than others? I'll be honest with you, I don't know. I don't know if one's more useful than the other. To me, I use this one more often, the one that's on top, just because it's a little more simple, looks a little prettier. But like I said, we could rearrange them lots of different ways, but I don't know what would be better than others. So right here, I have this. It says, Janet wants to calculate the time it takes to earn a certain amount of interest on a principal amount in an investment with simple interest. And then it asks, what equation could she use? Well, so I guess they're just giving us the equation. So in order to find interest, does anybody know the simple interest formula? You may or may not. That's okay. It's right up there in front of Bryce on the board. You can see I've got them stapled up there. It says formulas. Do you see the simple interest formula? I'm trying to see it from here. It looks like it's on the... That's it. I equals P times R times T. That's on the bottom, isn't it? What good eyesight I've got. I don't know how in the world I can tell. All right. So I've got I equals P times R times T. And this is what that stands for. The I is the interest. So does everybody know what interest is? Like when you're dealing with a bank and you get interest. So interest is money that they pay you for letting them use your money. Right? Or it goes the other way. If you borrow money from someone, then when you pay them back, you have to pay them interest. So that's what the I stands for. The P is the principal amount. All right? The principal amount is how much you put in yourself. So it's how much you invested or it's how much you borrowed, depending on what kind of problem you're doing. So if you were going to buy a $200,000 house and you didn't have any of that money, then you would be borrowing $200,000. That would be the principal amount. All right, the next one is the R. That's the rate. So this number is going to be a percentage. That tells me how much I'm going to have to pay back. So the lower the rate, the less I have to pay back. And then the T represents the amount of time that I have the loan for, or the amount of time that I've got my money in the bank for. So that's what all those variables represent. I equals PRT. Now, so this is the formula that we use anytime we're dealing with simple interest. Now, in this problem, Janet wants to know what? What's her question?
Calculate time to earn a certain amount.
She wants to know how much time is it going to take for me to do something? Well, what she wants is she wants time to be isolated. She wants the T to be by itself. Right now in this problem, the I is by itself. The I is isolated. So how could I get T by itself? Well, we just do algebra to get T by itself. Why is T not by itself? It's being multiplied by P and by R. So how can I undo multiplying by P and R? What's the opposite of multiplying by P and R? Dividing by P and R. If I divide by P and R, then they cancel. If I do it to one side, I have to do it to the other side. That's what keeps equations balanced. And so this says T is equal to I over P times R. So the amount of time she's going to have to leave that in the bank is going to be equal to the amount of interest she's paid divided by the principal and the rate. All right, so that's what we're doing. This is called a literal equation. We are rewriting a literal equation. It used to have the I by itself. Now I've solved it to get the T by itself. All right, that's all we're doing. Interest divided by rate and time equals principal. What do y'all guys think? Yes. That's correct. So D is the distance we want to travel. R is the speed or the rate at which we're doing it. And T is the amount of time it's going to take. So what are we looking for? We're looking for the average speed. Which one of these variables represents speed? R. That's the rate of speed, the rate we are traveling. So if I'm trying to solve for R, that means I want R by itself. R is being multiplied by T, so I can undo that by dividing by T. That tells me R is equal to distance divided by time. So now, this time I know some of those values. What is the distance Sarah has to travel? 6 miles. So in place of D, I'm going to plug in 6. And I also know the time it's going to take her. How much time does she have to get there? She has half hour. So we could write 30 minutes, but here's the problem. If we write 30 minutes, then the speed we're going to get is going to be in terms of miles per minute. Do we normally talk about miles per minute? Not normally. That's kind of funny to talk about. So I normally would rather talk about miles per hour. So how could I write 30 minutes or half an hour? 1/2, which you could either make a fraction or you can put 0.5 as a decimal. Either way. So now to find out what R is, we just plug this in. 6 divided by 0.5. When you do that, you're going to get 12. And again, we're talking about miles over hours. So that's 12 miles per hour. That's how fast she has to travel on her bike. You think? Yeah. Okay. 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 So how did you write a quarter down? Yeah, I like it. Yep. When you divide 2.5 by 0.25, that gives you 10. So she must ride her bike 10 miles an hour in order to get there before they close. For the width, we want to get W by itself. So again, think about an equation as a big wall, and you've got two sides of that equation. So why is W not by itself? It's being multiplied by 2, and we're adding 2 lengths to it. So I have to undo both of those things. Which one should I undo first? The one that's farther away. So if we get rid of adding 2 lengths, how could we do that? Subtract. Think about it. We're trying to get width by itself. Width is being added by 2 lengths. So the way I can undo adding 2 lengths is to subtract 2 lengths. So I do that to the other side. So that cancels. Then I've got perimeter minus 2 times the length equals 2 times the width. Now divide by 2 because the width is being multiplied by 2. So I'm going to divide by 2. So now I've solved my formula. It tells me the width is equal to the perimeter minus 2 times the length, and then divide all of that by 2. Now I know what both of these values are. I know the perimeter and I know the length. It tells me in the problem the perimeter is 144. And it tells me that the length is 40 inches. So I'm just going to substitute those two values in for P and for L. If you have a scientific calculator, you can put all this in at once. It'll do it all for you. And hopefully we all have a scientific calculator. So when I plug that in, that should be 144 minus 80 is 64. 64 divided by 2 is 32. So the width of the frame is 32 inches.
Two, or, yeah, 18 divided by 1 over 2 and
18 divided by 1 over 2. Okay. So, let's see. When we solve for h, we can get rid of b pretty easily. Divide by b. So now I've got a over b equals 1/2 h. So if h is being multiplied by half, what's the opposite of multiplying by half? Dividing by a half. Well, what does it look like when you divide by half? We don't normally like to divide by fractions because they don't work like we want them to. So in 5th grade, when you first started learning about dividing by fractions, you learned a way to do it easier than dividing by a fraction. We would multiply by the reciprocal. So we can multiply both sides by 2. So we could say that h is equal to 2 times a all over b. It's what the height formula should look like. And then if I plugged in 2 times 18 divided by 9, I would get 4, as was stated. C equals 5/9 times f minus 32. And then they've told us that it's supposed to be 190 degrees Celsius. We want to know what is that in Fahrenheit. So we're going to look at that equation. And again, this is the most difficult equation we've worked with so far because it has parentheses and a fraction. So just like yesterday, we want to get Fahrenheit by itself because we know what it is in Celsius. It's 190, and we want to know what should that be in Fahrenheit. So again, we're trying to get f by itself. It's not by itself because it's being subtracted by 32 and multiplied by 5/9. I've told you that our general rule is to get rid of the thing that is farthest away from 5/9, or farthest away from the f. In this problem, the thing farthest away from the f is the 5/9 because 5/9 is outside the parentheses where the f is inside the parentheses. So we want to undo multiplying by 5/9. Now, if you remember yesterday when we had a fraction, how did we get rid of multiplying a fraction? Multiply by its reciprocal. Yes. So I'm going to multiply the right side by 9/5, and I'm going to multiply the left side by 9/5. Now the 9/5 times 5/9 will cancel, and we're going to be left with 9/5 times c is equal to f minus 32. And now because this is the only thing over here, I can drop the parentheses because there's nothing outside the parentheses for me to do, so I can drop the parentheses. Now the f is still not by itself because it is being subtracted by 32, so I can undo that by adding 32 to both sides. And that's going to tell me that the Fahrenheit temperature is equal to 9/5 times C plus 32. Any questions about how we solve that equation? So that is, that's the most difficult one we've had. So if you got questions, let me know. Okay? So now, my final question was, well, what should the temperature be in Fahrenheit, given that it's 190 degrees Celsius? So now that I've got Fahrenheit isolated, I've got the F by itself, I am going to plug in 190 for C to see what the temperature in Fahrenheit should be. So when I plug in, I'm going to say Fahrenheit is equal to 9/5 times my C value, which is 190, and then adding 32. So again, great time to have a calculator. Hopefully everybody has one. So we've got 9/5 times 190 plus 32. And so I got that the Fahrenheit temperature is 374. That's correct. 374 degrees Fahrenheit. So which formula would we want to use here? Because we know what it is in Fahrenheit. So we would want the one where the C is by itself, because C is what we don't know.